the little planet Pluto, organized at the farthest reaches of our planetary gathering, is wrapped by countless viruses, divine bodies, and space rocks inside the Kuiper Belt, an immense neighborhood of space beyond Neptune. Once worried as the 10th planet, Pluto gets its name from the Roman master of the secret world. At any rate, in a critical moment in cosmic history, in 2006, Pluto was officially disadvantaged from its planetary status, reflecting the propelling perception of our vainglorious region. Our ongoing enthusiasm for the nearby planet group portrays a weaving of heavenly components, different space rocks, a select grouping of diminutive planets, and a count of only 8 classical planets. This encompasses the animals of human interest, spreading over many long periods of infinite discernment and examination. How we may decipher these endless bodies has flourished. We've obtained insights into their ceaseless methods of acting and expected legitimacy. A more nuanced picture of our vast environmental factors has emerged, yet in the middle of our growing data, the magmatic allure of our own reality continues to tempt examination and discovery. The James Webb Space Telescope, as the pinnacle of modern infinite development, stands prepared to unravel some of these waiting mysteries, including those involving Pluto. Not enduring its minute of size and mythical circle, Pluto held an exceptional spot in the hearts of many for a seriously prolonged stretch of time, boasting the distinction of being the smallest moon-bearing object in our planetary gathering. Pluto's renaming lit an intense response from the public, highlighting the significant connection people felt toward this distant heavenly body. Rational painstakingness coordinated that for an object to achieve planetary status, it must adhere to 3 vital models: revolving around the Sun, having sufficient mass to assume a nearly round shape under its own gravity, and its orbital path must clear its vicinity of junk. Pluto, with its eccentric orbital way, ultimately failed to meet these criteria. Pluto has gone through a fascinating evolution throughout the range of cosmic history. Initially, it encompassed any substantial celestial body seen overhead, including moons and space rocks. Pluto's discovery in 1930 by American space master Clyde Tombaugh sparked worldwide excitement, only to be followed by revelations of similarly sized objects within its vicinity, raising doubts about its planetary status. Amidst the ensuing debate, astronomer Mike Brown's groundbreaking discovery of Eris, a Kuiper Belt object comparable in size to Pluto, further muddied the waters, challenging the traditional definition of a planet. This led to a robust discussion within the astronomical community, culminating in Pluto's renaming as a dwarf planet during the International Astronomical Union (IAU) gathering in Prague in 2006. Thus, Pluto's transition from planetary prominence to dwarf planet status serves as a penetrating sign of the dynamic nature of scientific understanding and the endless quest for clarity amidst the vastness of the universe. It highlights the diverse exchange between insight, theory, and consensus building that characterizes the mission for knowledge in space science. After extensive debate, a redefined definition of a planet was proposed and put to a vote during the August meeting of the IAU, the authoritative body responsible for naming celestial objects and defining cosmic terms. In this gathering, astronomers grappled with the need to clarify the classification of celestial bodies, particularly those in the outer reaches of our solar system. Following discussions, dwarf planet status was conferred upon both Pluto and Eris. This decision was significant as it represented a departure from the traditional understanding of what constitutes a planet and reflected a more nuanced comprehension of celestial objects. Eris, recently known as the 23rd of 3113, was renamed after the Greek goddess of discord, reflecting the conversation and debates surrounding its classification. Mike Brown, a planetary scientist at Caltech whose work contributed to the renaming of Pluto, garnered widespread recognition for his role in the process. As a light-hearted jab at his association, Brown was affectionately dubbed Pluto Killer on Twitter. The revised classification prompted the rapid expansion and updating of educational materials, including banners and textbooks, to reflect the new understanding of Pluto and Eris as dwarf planets. However, not all members of the scientific community readily embraced the IAU's definition of a planet. Some planetary scientists, particularly those focused on Pluto, expressed skepticism about the new classification criteria. This divergence of opinion ignited ongoing discussions within the field of cosmology regarding the specific standards for categorizing celestial bodies. Researchers like me and others contributed to these conversations through scholarly papers that dissected established benchmarks in academic writing. They argued against the IAU's definition of a planet, referencing examples like Ceres, which was initially designated a planet upon its discovery in 1801 but later reclassified as an asteroid as more objects were found in the asteroid belt. The debate over the definition of a planet extended beyond academic circles into broader societal discussions. It raised questions about the nature of scientific classification and the implications of renaming long-established cosmic terms. Some expressed concerns that a narrow definition of a planet could constrain our understanding of the diversity of celestial objects in the universe. Despite these discussions, scientific inquiry continued unabated. In 2015, NASA's New Horizons spacecraft conducted a remarkable flyby of Pluto, providing unprecedented insights into this distant world. The mission revealed a dynamic and geologically active planetoid with features such as nitrogen ice, showcasing the complexities of this celestial body and reigniting interest in Pluto within the scientific community and beyond. Phanes and an obvious heart-shaped feature nearby enchant the public's innovative mind as we contemplate these upgrades. It ends up being apparent that how we could decipher the nearby planet group and its constituent bodies continues to develop. The renaming of Pluto and its designation as a small planet represents an accomplishment in our ceaseless examination of the universe, featuring the complexity and variety of worlds beyond Earth. As New Horizons sped through space at an amazing speed of 32,300 miles per hour, it was given an exceptional opportunity to capture distinct photos of Pluto's near side during its closest approach. However, due to the design of the bus and the position of the Sun, the most far-off side of Pluto often escaped view during the flyby. All things considered, analysts meticulously analyzed pictures taken by the rocket days before its encounter to secure pieces of information into this confusing region. Despite the challenges presented by the limited objective of these photos, they offered an incredible level of detail, allowing scientists to discern surface components down to around 1 mile across. This level of clarity far outperformed past observations, including those from the Hubble Space Telescope, which orbits Earth. The examination of these photos has yielded new perspectives on Pluto's dynamic nature. Scientists are delving into the landscape to unravel secrets like the potential presence of an ocean beneath the cold surface and the processes driving surface cycles. Some intriguing revelations even suggest the possibility of Pluto's harsh environment supporting microbial life. However, alongside these new discoveries come new mysteries. Recently found ice formations resemble high rises on Pluto's far side, with their origins shrouded in uncertainty. Richard Binzel, a planetary scientist involved with the New Horizons mission, aptly describes Pluto as the gift that keeps on giving as it continues to astonish researchers with its complexity. Before the New Horizons mission, the most detailed images of Pluto came from the Hubble Space Telescope, revealing a world with distinct surface features. Nevertheless, it was the New Horizons spacecraft that provided the first close-up views of Pluto's terrain, including the infamous heart-shaped feature in the vast frozen plain known as Sputnik Planitia. The discovery of Sputnik Planitia, with its striking arrangement alongside Pluto's largest moon, Charon, raised fascinating questions about its formation. Some scientists speculate that the plane's creation could have involved an underground ocean rising to the surface, causing significant gravitational shifts. Additional evidence supporting the presence of a subsurface ocean comes from the tumultuous terrain on Pluto's far side. This interplay of slopes, fissures, and fields bears resemblance to features seen on other celestial bodies where subsurface oceans exist. While the objective of pictures from Pluto's far side remains limited, scientists eagerly anticipate future missions for closer examination. The discovery of fractures and other geological anomalies fuels speculation about Pluto's underlying history and the possible role of its subsurface ocean in shaping its surface. These revelations challenge our understanding of planetary development and highlight the unique nature of distant worlds like Pluto. As New Horizons continued its endeavor, scientists assessed the fate of Pluto's rugged core. Ultimately, radioactive decay within the core would have generated sufficient heat to melt the surrounding ice. This process would have caused the ice to contract as it melted, leading to surface waves, much like the wrinkling of an apple stored in a cooler. If this scenario occurred, Pluto's surface should show signs of wrinkling and cracking in later photographs. However, when New Horizons captured images of Pluto's far side, it primarily revealed fissures rather than extensive wrinkling. These fissures suggest that Pluto's subsurface may have been liquid at some point before freezing over later. Notably, a massive fracture runs the length of the near side, extending from one pole to another. This fracture likely resulted from the freezing and expansion of the ocean, indicating the ocean's rapid cooling upon exposure to the frigid surface. The formation of this fracture suggests conditions favorable for marine life. Additionally, the dark red color of the ice, typical for organic compounds, points to the presence of complex organic molecules. Laboratory tests have shown that such particles could form through radiation, such as solar wind or cosmic rays, suggesting possible circumstances for their existence on Pluto. Other findings, including the identification of ammonia-bound ice on Pluto's near side, support the idea that the planet may contain rich organic compounds. While this does not imply the origin of life on Pluto, it suggests the potential for life to endure if conditions were right. Assessments from Pluto's far side have not only sustained the mission's objectives but have also prompted the discovery of intriguing surface features. For instance, ice mountains resembling high rises, scattered evenly across the landscape, present a significant mystery. Preliminary assessments indicate that these features are made from methane ice, forming a belt around the equator. However, their origins remain uncertain, with theories ranging from atmospheric freezing to breaking down under intense sunlight. Understanding Pluto's icy characteristics and environment requires extensive study of its atmosphere. Experts are refining climate models to better simulate observed phenomena and anticipate future conditions in laboratory settings. While the James Webb Space Telescope cannot capture high-resolution images of Pluto, its longer wavelengths make it likely to uncover surprising discoveries. As we continue to unravel Pluto's secrets, we embark on a journey representative of humanity's relentless quest for knowledge and the ongoing evolution of our understanding of the universe. We inch closer to answering profound questions about our place in the cosmos.